Hi everyone. So in this short video, we'll be looking at the gas laws, including the ideal gas law, the combined gas laws, and the graphs for the various laws such as Boyle, Charles, and the pressure law. Okay, so this first question asks us to use the ideal gas equation. And the ideal gas equation is simple. PV equals nRT. That's just something you need to learn. You won't actually have to do any calculations with this formula, but this is more like chemistry, and I'll show you the formula we use calculations for in physics. But here, P is the pressure of the gas, V is the volume, N is the amount of moles of the gas, R is something called the ideal gas constant, is a constant, and T is the temperature. Okay, as the last we'll be seeing of the PV equals nRT. This new formula here is called the combined gas equation. So our car tire is pumped to a pressure of that in the morning when the temperature is 23 degrees Celsius. Later in the day, the temperature rises to 34, sometime probably midday. Now we have to calculate the new pressure of the tire because of this increase in temperature. The volume of the air is obviously kept constant because the tire is not going to leak or anything. The same amount of air is in the tire, right? So the formula that we use is this. P1 V1 all over T1 is equal to P2 V2 all over T2. So in gas questions, we have three different parameters. We have the pressure, the volume, and the temperature. So P1, V1, and T1 is essentially pressure, volume, and temperature of the tire before any changes took place, before the temperature started to rise and thing in the day, right? And P2, V2, T2 is after something happened, after the temperature raised, right? So the volume of air is kept constant, which means that in our formula, we don't need to pay attention to the volume because it's the same thing, right? The volume does not change, so we could actually just scratch off the volume here from our formula, and we are left with P1 and T1 is equal to P2 and T2. Now all that's left to do is put in the values there. However, in gas questions, we don't use degrees Celsius. We use Kelvin. And to calculate Kelvin from degrees Celsius, all we have to do is add 273 to any degrees Celsius. So for example, in the morning when the temperature was 23, to get that into Kelvin, so 23 to Kelvin will be 273 plus the 23, which will be 296 Kelvin, right? And in later in the day, the 34, that will be 273 plus 34, and that'll be 2307, right? So 307 Kelvin. So now we will use the Kelvin values for the temperature. Okay, so the initial pressure was this is P1, so I'm going to put that here, 2 by 10 to the 5. The initial temperature is 296, and we have to calculate P2, so we leave that there, and then the final temperature is 307. So all we have to do now is make P2 the subject of the formula and solve for it. Alright, so I could easily cross multiply here. So I'm going to get 307 multiplied by 2 to the 10 to the 5 is equal to 296 P2. And to make P2 the subject, I just divide by the 296, right? So I end up with 307 by 10, 2 by 10 to the power 5 over 296. And I will put that into my calculator. Let's see what we get. So I am getting 2.07 by 10 to the 5. I'll leave my units just as they have it. Okay, so that is the new pressure in the tire. Okay, So this equation here can be used for all your gas calculations. The next part they want to see is the kinetic theory of matter to explain why the increase in pressure occurred. Well, it's very simple. Because of the increase in temperature, the gas particles have an increase in kinetic energy, which means that they will be bumping into each other a lot more often, and therefore the walls of the tire as well. So therefore the pressure will increase. Okay, so before we get into this new question, I want to just explain the graphs with the gas laws and also the 3 gas laws for you, right? So we have 3 gas laws. We have Boyle's law, we have Charles' law, and we have something called the pressure law. These are the 3 laws that you have to learn, but they are all based on the combined gas law. Okay, very simple. So essentially in Boyle's law, temperature is constant, right? So you see how like we had over here the volume is constant in this equation. Well, Boyle's law states that the volume of a gas is inversely proportional to the pressure when temperature is constant. But what you need to know is that here temperature is constant. Okay, that is important. Charles' law, pressure is constant. And obviously in the pressure law, volume is constant. Okay, so each of them has their own graph. Okay, so the Boyle's law graph looks like this. So we have volume here and pressure over here. So they would use the graphs would use the 2 that are not constant, right? So you see how Boyle's temperature is constant. Well, the graph will look like this. Okay, in Charles' law, actually we have to draw this one a bit different, and I'll show you why. We have temperature here, we have volume here, alright, and Charles' law looks like this. So this temperature here is in degrees Celsius, right? So at 0 degrees Celsius we would notice that the volume is still not 0. So we want the volume to be 0. So if we have to extrapolate the graph, so make an imaginary backspace into the graph, and we would realize that we would go at negative 273 degrees Celsius. That will give us the volume of 0, right? So this is why this is called 0 Kelvin here, right? 0 Kelvin, or absolute 0, right? So this is why the formula to calculate Kelvin from Celsius is plus 273, because we could see for 0 degrees Celsius, which is here, to get to 0 degrees from the negative 273, all we have to do is add back 273, right? So that's why to convert any degrees Celsius to Kelvin, you add 273. Very simple. And then finally for the pressure law is another simple one, right? So you have pressure, and we have temperature, and it's a straight line going up like that. Okay, so these are the 3 graphs for Boyle's, Charles, and the pressure law, right? So it's important for you to be able to describe the laws as well as draw the graphs and the formula, right? So obviously for the formulae, we're using the combined gas equation and just crossing off the one that is constant. So for Boyle's law, instead of P1 V1 T1 equals P2 V2 T2, if temperature is constant, we just get rid of it, and we end up at P1 V1 is equal to P2 V2. So you don't actually need to learn off the 3 different formulas. You just need to learn one and just cross off the one that is constant. For Charles' law, if pressure is constant, well, P1 V1 on T1, P2 V2 on T2, well, you just cross off the pressure. So you end up with V1 on T1 is equal to V2 on T2, and so on and so forth for the pressure law, right? Okay, so let's see if I have enough space to actually do the question over here, right? So they want us to calculate the ratio of the new volume to the old volume. So they want us to find V2 and V1. They do actually need to find V, right? Because they didn't give us any values for V over here in this question. Eh? No V's here, right? So it's a bit of a trick question. If the pressure is held constant while the temperature rises from 23 to 34. Okay, so in this one, the pressure is constant, right? So let's again bring out our combined gas equation. So if the pressure is constant, we get rid of the pressure. Bam. So now we are left with V1 on T1 is equal to V2 on T2. What do they want us to find? They want us to find V2 on V1. Isn't that what they want us there? Good. So we need to rearrange this formula in order to put V2 on V1. So we could cross multiply to get everything out of the fraction nonsense that is in right now. So by cross multiplying, we'll get V1 T2 is equal to V2 T1. So if I divide by V1, I could get the V1 underneath the V2. So I will do that. So T2 will be equal to V2 T1 over V1. And finally, to get rid of the T1, I just need to divide by T1 now. So dividing by T1, I will get T2 on T1 is equal to V2 on V1. And this is what we want. So V2 on V1 will be equal to T2 on T1. And don't we have those values? So T2 is the final temperature. And what we said it was, not in Celsius, it was 307 Kelvin. So it's going to be 307 over 296. You put that in your calculator and you will get the ratio. That's what they wanted. You will get 1.04 to the nearest 2 decimal places, right? That is the ratio of V2 to V1. Very simple question. All right. A piston traps a mass of gas in a cylinder. At 25 degrees Celsius, the pressure of the gas is 5 atmospheres when its volume is 50 ml. Calculate the volume of gas if its pressure drops to 1 atmosphere at a constant temperature. So again, it's the same thing, right? So you put your combined equation at constant temperature, you cross off your temperatures, bam. So you end up with this now. P1 V1 is equal to P2 V2. So P1 is 5 atmospheres, so you can just put 5. V1 is 50. So you multiply by 50. And we need to calculate the volume. So the pressure will drop to 1. And then our volume will be V2. So 1 V2 is still V2, right? So it's actually a very easy calculation. You just need to multiply 5 by 50. So you get 250 ml is equal to V2, and that's your final volume, okay? Okay, so after resetting the piston, the gas returns to its initial pressure and volume. If the volume is now fixed while the gas is heated to 60 degrees Celsius, calculate the final pressure. So again, I'm going to write back my formula because I don't want to be confused. Right, so the volume is fixed. So I cross off the volume. So I am now left with P1 on T1 is equal to P2 on T2. Okay. So the initial pressure, again, is 5. The initial temperature, they should have given us the initial temperature at 25 degrees Celsius. But of course, we are not going to use 25 degrees Celsius. We are using 273 plus 25, which is 298. So 298 Kelvin. And they want us to find the pressure. And the next temperature is 60 degrees Celsius. So that's 273 plus 60 will give us 333. Okay, and to find P2, we will cross multiply. So we will get 5 is equal to 298 P2. And to find P2, we just divide by 298, right? So you got the 5 multiplied by 333, then divide by 298, and you will get P2. So we put this in our calculators. So the new P2 is 5.59 atmospheres, right? That's the unit that they chose to use this time. And there you have it. So all the gas laws can be calculated the same way using this magic formula here. All right. What you have to do is to learn the graphs, learn how to describe Boyle's law, Charles' law, and the pressure law, and also know that you need to convert degrees Celsius to Kelvin for gas laws. Okay, and that's the end of this video.